guys, welcome back to A-Level Lessons Online. Hope you're having a fantastic day during this quarantine period, right? Or just stay at home, okay? May holidays are coming really soon, in the next week, right? And I'm going to be doing a video on PNC, right? Permutations and Combinations, right? Because I posted something on Reddit and a lot of you guys have been requesting for this, surprisingly. So I thought that I would go through it since some of you guys are having a bit of qualms about it. Then if you have any questions, you can leave it for me in the comment section below and I will answer them for you, alright? So this is just going to be like a mini recap, I would think, for most of you guys, or maybe just even an introduction, or hopefully a easier, more concise way of looking at PNC and how to do such questions, right? So this one I'm going to be doing more of the basics, okay, what PNC is about, what you need to know about PNC. And then subsequently down the road, I will be releasing topical questions on how to do a PNC question, okay, what you should be looking out for. So hopefully this kind of like kickstart or either that can help you to understand better what PNC is all about. Alright, so let's just go through what the definition of permutations and combinations are. So P and C. Alright, so permutations, begin with permutations. Okay, permutations you need to know, right? It is essentially an ordered arrangement of objects. Okay, so it is just an ordered arrangement of a number of objects. Okay, so the number of objects doesn't matter. It can be 100, it can be 5, it can be any amount of objects, okay, but it's essentially an ordered arrangement. Okay, the keyword here is ordered, okay, which means that when you're looking at a permutation, it has to be in a certain order. Okay, on the other hand, combinations, okay, the combinations definition is a selection. So combination and selection can be used interchangeably of a number of objects from a given set, okay, that, or maybe I shouldn't use that, okay, let's use comma where the order of selection is not important. It's not important, right? This will be very, very useful later on down the road, okay, when you're looking at questions and you're considering, okay, do I have to use a permutation method or do I have to use a combination method? Alright, so I'm just gonna look at permutations first. Okay, we'll look at combinations later. Okay, let's look at permutations, right? What permutations is all about. Alright, so a lot of you guys will have learned about this thing called factorial. Correct? If you learned about this thing called factorial before. So essentially, permutations have got 4 main key results. Okay, the first key result, okay, is that the number of arrangements of, let's say, n different objects is very simply going to be n factorial. Okay, when I have something that is n factorial, I'm basically saying that, let's say if n is 10, let's say it's 10 factorial. Okay, let's say if n equals to 10, I'm basically going to be taking, as you guys know from the definition of factorial, it's just the total number of objects or numbers in this case. You're just going to multiply it by one another. It'll just be 1 times 2 times 3 times 4 times all the way until I have a times 9 times 10. Okay, so this is the same as 10 factorial. So essentially, I'm saying that there is going to be 1 way, 2 ways, 3 ways, 4 ways. Okay, there are going to be 10 different ways of arranging the number of objects in, let's say, a certain row. Okay, so that's going to be a first key result. Okay, that a permutation, very simply, is kind of like, think of it as, let's say there's a boy over here, a girl, let's say a father, and a mother. So in this case, right, they can basically stand in 4 different positions, correct? The girl can come first, followed by the boy, the father, the mother, right? But each one of them can stand in a specific position. For example, the boy can stand in this position, he can stand in this one, or this one as well. So he has got one position, the second position here, the third position here and the 4th position here. So as a result, for them, 4 of them to actually reshuffle, okay, because they are not identical, it is very simply just going to be 4 factorial. Okay, reason being is that let's say if the boy takes position 2, it means that one of them has to take position 1. 2 of them cannot be standing in the same position. Okay, let's say if they're all standing in a row. Alright, so there's only 4 different ways of permutating this case over here, which is just going to be very simply 4 factorial, which is just going to be 1 times 2 times 3 times 4. Alright, so that's how you're going to look at the first result. So this is just it's the most basic. Okay, it's a very general way of just understanding that the number of arrangement of certain number of objects in a row would just very simply be n factorial. So it's the number of positions and then you multiply it by the factorial. Okay, the second one would be that the number of permutations, I'm just going to give it a I just read out the whole thing. Number of permutations of n different objects taken r at a time without repetition is going to be n c r, which is basically choose. Okay, c stands for choose, times r factorial. Okay, so this one, what does it mean? Okay, this one basically means that let's say if I've got a n number of objects, let's say 10 objects. Okay, and let's say that I am going to be taking certain objects and taking it out of, let's say, this bag. Okay, what happens is that I'm going to be choosing, okay, the number of objects that I'm going to be taking out, and I'm going to permutate, okay, which is the r factorial over here, permutate the number of times or the number of ways they can also be taken out. Okay, so I give an example. For example, let's say I've got a bag over here. This looks like a pineapple. Okay, but let's say it's a bag. Okay, and I've got a bunch of, let's say, cards inside. Okay, let's say I've got 10 cards. Okay, let's say the question asks you to choose 2 cards, okay, from this bag. Okay, so your answer will very simply be 10, choose 2. But because the thing is that you can, for example, let's say one of them is a red card, one of them is a blue card. Let's say you take out the red card first, followed by the blue card. Okay, that is one way of doing it. But there's also another way that you can permutate this way of taking out, which is if you take out the blue card first, followed by the red card. So you can take out the red then blue, or the blue then red. So it can be the red then blue, or the blue then the red card. So there's going to be 2 ways you can permutate this whole thing, because there's the first way, which is the red then blue, then the blue then red. So you have to take this 10 choose 2, which means that you have chosen 2 cards out of the bag, and you have to take these 2 of them and multiply it by 2 factorial. Okay, so let's say if I give you a scenario, okay, whereby I take out 5 cards. Okay, let's say if I take out 5 cards, it will be the same thing. Out of the 10 cards, I will choose 5. And then out of these 5 cards, because it's similar to just now, the first part, okay, I can arrange them, okay, I can take them out in different orders. I will have to permutate them as well. So I'll take it and multiply it by 5 factorial. Okay, which is why this definition over here, n choose r times r factorial. Okay, this is the r, the 5. And my n is going to be the number of them in the bag, and my c means to choose. Okay, I choose 2 of them out. Alright, so I've gone ahead to edit out my writing over here. Okay, essentially before I move on to the third case, previously I mentioned 2, it's actually 5, so it's then choose 5, not 2, times 5 factorial, right? So that's for that question. Okay, so next part will be the third scenario, okay, the third result, okay, which is when the number of permutations of n different objects taken r at a time with repetition. Okay, so this one is when we're looking at a case whereby there is repetition. So for example, let's say I give you a whole row of 10 different numbers. Okay, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 10 different numbers over here. So let's say if I tell you that from these numbers, I want you to just select 3 of them. Okay, so if you're going to select 3 of them, each one of them are going to have an equal number of a chance, right? Because I didn't say that you have to take it out and then it cannot be replaced. So in this case, I'm saying that there is going to be a replacement of it, which means that even if you take out one, there will still be another one to choose from. Okay, it doesn't mean that the one you've taken out is gone forever. So in this case, let's say if I choose 3 random numbers, I'm going to have a 10 over here, okay, because let's say this is the number of chances of taking one of these numbers. and I'm going to do it 3 times, which is going to be times another 10, since there's no replacement, times another 10, which is just going to be 10 to the power of 3. So you can see over here that says I'm asking you to take it out 3 times. I'm asking you to take out 3 numbers 3 times. My r is equals to 3. The number of objects I have here is 10. That's why the formula of n to the power of r, which is just 10 to the power of 3 in this case, right? So this is the event whereby I have a repetition, which means that I do replace the objects, okay, every time I take out one of them. So even if I take out 2 of them to be number 5s, okay, I still have another 5 left, which means that it still has a 10 out of 10 chance of being selected in this permutation. Alright, so this one I'll have 10 cubed, which is going to be 1,000 permutations. Alright, then the next last result for permutations, number 4. Okay, this one is going to be whereby it is known as identical objects. Alright, so identical objects are a bit more interesting. Okay, for instance, let's say I have a whole row, okay, of different colored cards, for instance. Okay, let's say I've got a red, I've got another red, I've got a blue, then a yellow, another blue, and let's say a purple. Alright, so if I'm going to ask you the number of ways in which I can permutate these 1, 2, 3, 6 cards, okay, it's very simply going to be, as you have learned from the first key result, 6 factorial. Okay, but the issue here is that I have got identical objects. Okay, 2 sets of cards here are actually the same, which means that let's say if I have this red over here and this red over here and I swap their places, they will look exactly the same. Nothing is going to change. Likewise for the blue cards, which means that I will have to sort of like take out, okay, certain ways in which these objects can permutate, which is why I have to divide it by 2 factorial, which is for my red cards, and another 2 factorial, which is for my blue cards. So the yellow and purple, they can still permutate around, but I will have to divide the overall result by these 2 because they're identical, which means that if they take each other's places, that means that they are essentially doing the same thing. So there's extra ways that we are accounting for, which we have to make sure we get rid of. Alright, so the overall idea for this part is that in a set of n objects, if there are n1 of the first kind and let's say nk of the kth kind, okay, the number of permutations would very simply be the formula that you have just seen, is n factorial, which is the total number in the whole row. Okay, then you're gonna want to divide it by your n1 factorial, and let's say in this case your nk factorial. Okay, so as long as there's identical objects, you have to make sure that you divide it, okay, not multiply, divide it, okay, by in the event whereby you do permutate the 2 objects, the 2 identical objects, you have to divide it so that you're gonna like getting rid of those identical objects. Alright, okay, then the next part we're gonna be looking at combinations or selections, right? They're the same definition. So combinations are basically a selection. Oh, I've already stated it up there, didn't I? Okay, so the combinations, right? Your key result that you have, okay, would be the number of, so the number of ways of selecting our objects from a given set of n different objects. Okay, likewise it's going to be like the same as your key result 3 just now. Your key result 4. Key result 2 is known as a combination of n objects. Okay, taken r at a time. So therefore, the number of combinations is very simply going to just be n choose R. Okay, reason being why it's just n choose R is because, like we've said, the order does not matter. So there isn't a need for you to have to go and multiply by R factorial to rearrange them, make sure they are in order. There isn't a need to do that, okay, because this is no longer permutation. When you're looking at combination, okay, the question will state specifically, right? But when you're looking at combination, there is no need to actually arrange them at all. So which means that if you're going to let them just, let's say they are all in one whole row, right? Essentially what happens is that in this whole row, they can just move around anywhere they want. Right, what you're going to do is you're going to take the number of objects, which let's say in the event by n equals to 10, and then let's say I ask you to choose 4 of them. So you will choose 4 of them. Your answer will just be n, your n, which is 10. Okay, you're just going to choose 4 of them, and you're just going to let the 4 of them go wherever they want. So there is no need for you to multiply by 4 factorial, which means that they have to take a specific slot of that chosen 4 slots. There isn't a need to do that. Okay, you can just let them go and insert themselves anywhere they want. Okay, so this result, if you need the factorial form, is n factorial over r factorial times n minus r whole thing factorial. Alright, okay, the second last part, sorry, okay, would be your insertion method. So insertion method, okay, this one is very specific. Okay, let's say I have got a whole row over here. Let's say I've got 1, 2, 3, 4, 5, 6, 7. And let's say I tell you that I need to insert 2 people. Okay, but they cannot be standing next to each other. Alright, so the question always says something like they cannot be seated next to each other, they cannot be standing in the row next to each other. So whenever you see those keywords, it means that you have to insert them. So what you do is you will draw arrows at the areas in which you can insert them. Let's say this is Alpha, Bravo, Charlie, Delta, E, F, G, and let's say I say X and Y, they cannot stand next to each other. So what you will do is this X and Y, they will be inserted, okay, amongst these arrows. So what you have to do is you need to first, okay, the number of ways, you need to first always remember, because they are standing in a row, they have to be permutated first. So what you do is you take A, B, C, D, E, F, G, which has 7 of them, you will take 7 of them and you'll permutate. So 7 factorial. Okay, after that, you take this and then you will multiply it, okay, by, let's say, when you insert the 2 of them, which in this case, I'll have to choose 2 slots out of the 1, 2, 3, 4, 5, 6. Okay, let's say they have to be in between, right? So I'm just talking about these slots. Okay, they have to be in between the guys of let's say these alphabet names over here. So they have to be in between them. They cannot be beside them, or they cannot have anyone that's not next to them, which is why there's only this 1, 2, 3, 4, 5, 6 slots. So what I'll do is that I'll take this and I'll multiply it by 6 slots, and I will choose 2 slots for X and Y. And lastly, don't forget, because we're looking at permutations here and it's not a combination, okay, they cannot if it's a combination, they can just be standing next to each other, so it's not allowed. So I have to make sure that I order them as well and permutate them, which is why I'll take this and multiply it by 2 factorial as well. Which means that at any one time, only one of them can be standing in one of the specific slots. Okay, the 2 of them cannot be standing in the same slot. Okay, if you don't include this times 2 factorial, what happens is that they can actually be it's a combination, which means that they can just be anywhere they want at any time. Okay, all you did was you just took the 6 slots and you chose 2 slots for them to be in. Alright, so this is not allowed, okay, because they are also per se, they are basically not the same person, right? They are 2 completely unique identities. So what you have to do is you will still need to take it and multiply it by the 2 factorial. Okay, and this will give you your answer over here. Alright, so lastly is if you have a circle. So if you have a circle, it's very simple. In the circle, the formula will always just be n minus 1 factorial. So let's say if I've got 1, 2, 3, 4, 5, 6 slots. Can I ask you how many ways can the 6 of them permutate? Your answer will just be 6 minus 1 factorial. It should give you 5 factorial. Okay, circles is always the same formula. It's very easy. Likewise, they can always combine circle with insertion. So if you need to insert, just draw the arrows. 1, 2, 3, 4, 5, 6. Okay, and likewise, you can always, let's say if they want you to choose 2, it'll be 6, choose 2 of them, and make sure you remember to permutate the 2 of them. So that will be your answer. Alright, so quite a simple part of this. Case circles is always very, very easy to do. So essentially that is actually all that you need to know for P&C. Alright, I know that it's a bit more complicated at the moment. Okay, the reason being is because it's new to you, right? P&C is something that is new, and I don't exactly have concrete examples here to use, okay, which is why I said this one is just the basic, okay, the key results that you need to know. In my next few videos, okay, I will make sure to have a lot of questions that will come out, and you can take a look at those questions, right? See if it helps. I think P&C is something that, in essence, on itself, just looking at words, okay, may not be able to fully explain it. Okay, you must be able to practice and see how to actually apply it when it comes to questions, right? Because like over here, is if I just tell you that, oh, it's just a bunch of them taken out at a time, it's very hard to actually understand and see it. But if you look at the questions that we will be doing, you will see that it's actually much easier to understand, and you will know what steps to take as well. So for now, just go and understand from this video, okay, what the key results are and how to come about doing it using these basic examples. Then when it comes to the actual exam questions, okay, we'll look at how to answer using which result of these 5 main results over here. Alright, so if you enjoyed this video, okay, be sure to give it a like as well as to subscribe to the channel. It doesn't cost you anything, it's free. So feel free to do that. And if you have any questions, you can leave it in the comment section below. I will answer it as well, and let me know what else you want to see. And do go ahead and just share this with your friends if they need help as well. Alright, so if not, I'll see you guys in the next one. Have a good one. Bye bye.